Welcome students. Our today's topic is area between two curves. If we have two curves g of x and f of x, if our upper curve is y is equal to g of x and lower curve is y is equal to f of x, if x equal to a and x equal to b are the straight lines, then area between two curves g of x and f of x is shown in figure. This area can be found by using definite integral. Area is equal to integration a to b g of x dx minus integration a to b f of x dx. First integral represents area between the curve y is equal to g of x and x-axis, and second integral represents area between the curve y is equal to f of x and x-axis, and difference of these two area is basically area, which is shown in the figure. This area can also be written as integration a to b gx minus f of x whole dx. Now area between two curves can also be expressed in one another form. That is, if our two curves are like this, if our first curve is x is equal to f of y, and the second curve is x is equal to g of y. If y is equal to d and y is equal to c are the straight lines, then area between two curves g of y and f of y can be represented as integration c to d, that is our area is equal to integration c to d. Our upper curve is here g of y dy minus integration c to d. Lower curve is g of x f of y dy. Lower curve is f of y dy, and it can also be expressed as integration c to d g of y minus f of y dy. Now we solve a question. Sketch the region bounded by the curves y square equal to x plus 4 and y square equal to 2 minus x, and find area of bounded region. First we sketch the area bounded by these two curves, as these two curves represents parabolas. So first we sketch the graph of these two curves. Our first curve is y square equal to x plus 4. It can be written as x is equal to y square minus 4. Now this equation is quadratic in y. Here coefficient of y is y square equal to 1, so a is equal to 1, b is equal to 0, which is the coefficient of y, and c is equal to minus 4. Now we find vertex of this parabola. y coordinate of vertex is equal to y equal to minus b upon 2a, as b is equal to 0, which implies y is equal to 0. When y is equal to 0, our equation 1 becomes 1 implies, putting y equal to 0 in equation 1, we get x is equal to minus 4. Now vertex for our first parabola v1 is minus 4 comma 0. Now we find vertex for second parabola. Our second equation is y square is equal to 2 minus x. Y square equal to 2 minus x. Again, we find the value of x, and x is equal to 2 minus y square. This equation is quadratic in y. Here a is equal to minus 1, b is equal to 0, and c is equal to 2. Now we find the vertex of this parabola. The y coordinate of vertex is y equal to minus b upon 2a. Again b is equal to 0, which implies y is equal to 0. Now x coordinate of our vertex can be found by putting y equal to 0 in above equation, which is our equation number 2. So equation 2 implies x is equal to 2, which implies vertex for our second parabola v2 is equal to v2 is 2 comma 0, 2 comma 0. Now we have enough information to sketch these parabolas. The vertex for first parabola is minus 4 comma 0, and as a is equal to 1, which is greater than 0, so our first parabola opens rightward. So our first parabola is 1, 2, 3, minus 4 is our vertex, and it opens rightwards. First parabola. Similarly, we can sketch second parabola. Now vertex for our second parabola is 2 comma 0, as a is equal to minus 1, which is less than 0. So our second parabola has vertex at x equal to 2 comma 0, and this opens leftward as a is equal to minus 1, which is less than 0. So our second parabola looks like this, and the equation of second parabola is x is equal to 2 minus y square. Vertex of this parabola is at 2 comma 0, and the vertex of first parabola is at point minus 4 comma 0. Now we need point of intersection of these two parabolas. For point of intersection, we find point of intersection by using these two equations, that is x equal to 2 minus y square and x equal to y square minus 4. For point of intersection, we solve two equations. The first equation is x equal to 2 minus y square, 2 minus y square, x equal to 2 minus y square, and the second one is x equal to y square minus 4. X is equal to y square minus 4. 2 minus y square is equal to y square minus 4, which implies y square is equal to 6. y square, 2y square is equal to 6, which implies y square is equal to 3, which implies y is equal to plus minus under the root 3. Now, by putting these values in above equation, we can find the value of x. So putting y is equal to plus minus 3, x is equal to 2 minus 3, which is equal to minus 1. So our point of intersection is one point is minus 1 comma plus under the root 3, and the second point is minus 1 minus under the root 3. So point of intersections are minus 1 under the root 3 and minus 1 minus under the root 3. Now we can find area of this bounded region, the region that is bounded by two curves, by two parabolas. Remember, this is our line y is equal to plus under the root 3, and this is our second line y is equal to minus under the root 3. Now we can easily find this area of this shaded region. Remember, this is our type 2 region. It is bounded below by the line y equal to minus under the root 3 and above by the line y is equal to under the root 3. Of the upper curve in this case is x equal to 2 minus y square, and the lower curve is x equal to y square minus 4. So our area is equal to, in this case, area is equal to definite integral from minus under the root 3 to under the root 3. Our upper curve is 2 minus y square minus the lower curve is y square minus 4, y square minus 4 dy. This square is with y, only y square means 2 minus y square, not 2 minus y whole square. Now we solve this integral. This integral can be written as minus under the root 3 to plus under the root 3, 2 minus y square minus y square plus 4 dy. It can also be written as 2 times integration 0 to under the root 3, 6 minus 2y square dy. Now we solve this integral. This is equal to 2 times integration 0 to under the root 3, 6 dy minus integration 0 to under the root 3, 2y square dy. This integral can be solved as 2 times integration 6 dy means 6y, and y varies from 0 to under the root 3, minus 2 times integration becomes y cube upon 3, and y varies from 0 to under the root 3. This is equal to 2 times it becomes 6 into under the root 3 minus 0 minus 2 upon 3 under the root 3 whole power 3 minus 0. Now it can be written as 2 times 6 into under the root 3 minus 2 upon 3. Now under the root 3 whole cube can be written as under the root 3 square into under the root 3. So it becomes under the root 3 square is 3 into under the root 3 now 3 is cancel out here and we can write it as 2 into 6 into under the root 3 minus 2 into under the root 3. It can also be written as 2 times 4 into under the root 3, which is equal to 8 times under the root 3.